Okay, what we're going to do here is just kind of make some connections between quadratic functions and their formula. So what I've done is I've graphed the parabola, or three different parabolas, just to show some different aspects of quadratic functions. The first parabola, this blue one here, you'll notice that it comes down and touches, but does not cross the x-axis, and then kind of goes up on either side from there. This one is going to have what's called a double root, meaning that the same solution occurs twice. Usually in a quadratic function, if you remember back here where we found some solutions to equations, we got two solutions. Well, if you get the same solution twice, then on the graph what it's going to look like is where it touches and it goes back. So that can happen either from below or from above. That part doesn't matter. But it does happen sometimes. In the green one, you'll notice that there are two solutions. We also call these zeros. All right, so zeros, sometimes also called roots, are basically x-intercepts. Okay, so it's the place where the parabola crosses the x-axis. So this one has 1 0. This has 2 zeros, and this one, the red one, has no zeros, or no roots. And that'll become significant later. This is what a quadratic function looks like in standard form. And so we have a coefficient on the quadratic term, we have a coefficient on the linear term, and we have a constant. The only term that has to be here in order for this to be a quadratic function is that one right there. All right, we could have nothing for a linear term, we could have nothing for a constant term, and it's still a quadratic function. Now, there are some important things that we can figure out based on the graph, or about the graph based on the function. The first is this. All parabolas are going to have a y-intercept. The y-intercept for this red one is going to be way, way, way off the page, but it'll be there somewhere. This y-intercept you can see on the blue one. You can also see the y-intercept here on the green, which happens to also be one of its zeros. So y-intercepts, remember, is what you get out of the function when you put 0 in for the input. All right, it's the vertical intercept. Well, if you think about, no matter what a, b, and c are, if I put 0 in for my x's, there's only one thing that's going to be left. C. So C, if you get your formula in standard form, C is always going to be the y-intercept. Now you could also have a function in what we call factored form. Factored form is y equals a times x minus r times x minus s, where r and s are zeros. All right, and so there's always kind of this factor here, a, that that is necessary for basically how expanded or skinny your parabola is. And we're going to work through that as we talk about how to develop the formula for a function based on a couple of points in the graph. This is just a quick reminder of some of the connections for quadratic functions.